in an earlier section, we talked about two properties that we're going to dive deeper into today, the transitive and the substitution property. So today's notes, the goal is to focus in a little closer and to see what it looks like to use these and then add them also into some typical context we're going to see right now with supplementary angles, complementary angles, and the other types of concepts we've been working so far with in chapter 2. So I'm going to redefine them here for us and then give you an example of what this might look like. So the transitive property says it can be said one of two ways, and both are used here as a theorem. Transitive property option 1 says if segments or angles are congruent to the same segment, then they are congruent to each other. So an example of this, let's use segments for this. I'll use angles for the next one. Let's say that I have some segment AB, and the problem tells me this is congruent to CD. So some segment AD is congruent to CD. And then let's also say that they told me that BC, so hold on, let me go back. AB is congruent to CD. Let's also say they tell me that DE is congruent to CD. Both segments AB and DE are congruent to CD. By the transitive property, this allows us to conclude that therefore segment AB also has to be congruent to DE, and we can support this with the transitive property. Similarly, I think this is the definition I gave you in class, if segments or angles are congruent to congruent segments or angles, then the original angles are congruent to each other. So this is going to take 3 statements to work through our chain, but this is really helpful, and this is why the transitive property can connect a whole bunch of things for us here. So I'm going to use angles because the numbers are easier to see here. So let's say first angle 1 is congruent to angle 2. Let's also say that angle 2 is congruent to angle 3. And let's also say here that angle 3 is congruent to angle 4. What I have here is a link between these. Angle 1 is congruent to angle 2, but angle 2 is congruent to angle 3. Both angle 1 and angle 3 are congruent to angle 2, but angle 3 is also congruent to angle 4. This forms, the easiest way to think about it is like the logic statements we set up, a chain, all the way connecting that angle 1 and angle 2 have the same measure, but angle 2 and 3 are also congruent, but angle 3 is also congruent to angle 4. This allows us to conclude, therefore, that angle 1 is congruent to angle 4 by the transitive property. Now, in all honesty, it's always been a little confusing to me, the transitive property wording, segments or angles are congruent to congruent segments. Easier way to see what this looks like in reality is that the different segments or angles that we have, we could line them up in a chain that leads one section to another as we work these through. And then we're going to next look, as we see this, from 1 to 2, 2 to 3, and 3 to 4. That gives us a connection all the way back between angle 1 and angle 4. You want to think about the transitive property is when you have multiple chains of congruent angles or segments, and there are angles or segments that show up in each of those chains. So you can form a connection between them to then connect the beginning and the end angles or segments are congruent. Substitution property is going to work more in the idea of replacing. So looking here, instead of giving you a formal definition, I'm giving you more of a description this time. So we use substitution in algebra, replacing one expression with another. If objects are congruent, we can also replace them. We can also replace in geometry one object with another, and then that creates for us a new statement. So in this case here, what we would need is a statement in which we want to replace, and then a pair of angles or segments that are congruent to each other. So let's first start and say I know something like angle A is congruent to angle B. And then also they give us another statement that is not talking about congruency, but something else. So maybe they tell us that angle A is complementary to angle E. Angle A is complementary to angle E. This would go with a diagram with a specific situation that we have, but we are doing it generally here. So what this means is that I can make a new statement by substituting angle B into place for angle A here. That would mean angle B is also complementary to angle E, and this is by substitution. I am substituting angle B in place of angle A. Now there's nothing specifically that we're just replacing. So it's not something in the diagram that helped me conclude this. I only knew it because we can replace congruent angles in for each other to make new statements. So let's go ahead and look at a more complex example of how this works out. Angle 1 here says BC bisects angle ABD. Looking at that, that would allow me to conclude that angle 1 was congruent to angle 2. So I can go ahead and mark those. And while we're working, there'll be a couple of logic thoughts. I'm going to show you the method today of proving and stating things as we go, and then seeing how they come in to be useful. So BC bisects angle ABD was the given. And angle bisectors show up a whole lot. Remember, it allows us to conclude the two angles inside of that larger angle have to be congruent. So that means that angle 1 has to be congruent to angle 2. This is by if we have an angle bisector, then it divides the angle into two congruent angles. Okay, so I've pretty much taken that first given right now as far as I can take it. It bisected the angle. I wrote that those angles then had to be congruent. So I've pretty much finished that angle, or that given. It also tells me that angle 1 is supplementary to angle 4. Well, that's cool. That means that together, angle 1 and angle 4 would have to add up to 180. Let's go ahead and add this into our diagram now. Angle 1 is supplementary to angle 4. And that was also given. So now our goal is to prove that angle 2 is congruent to angle 3. At this point, we got to figure out what we know about these angles. I know something thus far about angle 2. I know that angle 2 is congruent to angle 1. So thinking about this, any place I see angle 1, I can replace it with angle 2, which could be helpful because here it says angle 1 is supplementary to angle 4. That would allow me to replace it if we wanted to. I could prove that angle 2 is supplementary to angle 4. So that's something to maybe make a note of. So I'm just going to write this here as we plan this out. We could, doesn't mean we have to, but we could prove using substitution angle 2 is supplementary to angle 4. Well, the idea is, does that help us? Well, so far I haven't said anything about angle 3. Now's when we turn to our diagrams. Looking here, angle 3 and angle 4 form a straight angle. That means they are supplementary to each other. That means I could prove angle 3 is supplementary to angle 4. That means I could show both angle 2 is supplementary to angle 4 and angle 3 is supplementary to angle 4. That seems like that's going to be useful. So let's keep going with this and see what we can do. So as we said, it seems like it will be useful to use substitution here. Substitute 2 into the place of 1 to prove angle 2 is supplementary to angle 4. This was by substitution. And the next step, we need to prove angle 3 supplementary to angle 4. Before we do that, we have to say the angle is actually straight. So angle ACD is a straight angle. And this is assumed from diagrams. Straight lines are one of the only things we can assume from a diagram. And now that I've set it straight, I know that 3 and 4 form that straight angle. I can say that angle 3 is supplementary to angle 4. This is by if two angles form a straight angle, then those angles are supplementary. So if two angles form straight angles, then they are supplementary. All right, the goal is to prove that angle 2 is congruent to angle 3. Now we have a connection. Angle 2 is supplementary to angle 4, and angle 3 is supplementary to angle 4. That means they are both supplementary to the same angle, and we sure have a theorem that lets us use that. That means angle 2 is congruent to angle 3 because they are supplementary to the same angle. So if two angles are supplementary to the same angle, then those angles are congruent. And this is so important that we say they're supplementary to the same angle. They have to be supplementary to something in common in order to prove them congruent. So that was a longer proof, but now you can see how substitution can work as a sub-step in the process along the way. It just gives us a lot more options to work with as we're able to replace angles in for one another, or we can alternately do that with segments. So before we look at another example, I'm going to shrink this down. Okay, and we're going to look at example number 2. So for example number 2, it says angle 1 is congruent to angle 2. So let's get in the habit of marking our diagrams. I know these two angles are congruent. Our goal is to form or to prove that angle 1 is supplementary to angle 3. So I only have one given, so let's go ahead and add that into our proof. Okay, let's think of the ways that we can prove something supplementary. Either I could prove angles supplementary because I can see visually that they form a straight angle. Well, that doesn't work here. Angle 1 is not adjacent or next to angle 2, so I can't verify it that way, or angle 3, I can't verify it that way. They're in different locations in this diagram. Or I could prove other segments or other angles supplementary, and I could use substitution. So is there a way that I could substitute 1 in place of 2? So looking here though, there's a nice connection that 2 and 3 form a straight line, making them supplementary to each other. Once we prove that, I could use substitution to prove 1 supplementary to 3. So then we need to prove it. As we've seen, we need to first say the angle is straight. We're naming it as an angle. The vertex is at R. So with this vertex at R, if you pick M or A, doesn't matter as long as you put R in the middle. So we could call this angle MRK or ARK, either one works. Angle arc is a straight angle. And this is assumed from diagram. And now that we've said it's straight, we can then say that these angles are supplementary. So angle 2 is supplementary to angle 3. Think about why we know this. Looking at the diagram, they are adjacent to each other. They together, next to each other, form a line. So this should be if two angles form a straight angle, then they're supplementary. Okay, now looking here. In order to say that angle 1 is supplementary to angle 3, I'm not trying to use any of my fancy supplement theorems. I don't want to prove anything congruent. I just want to get a new statement to show those measures would be supplementary. They would add up to 180. So this is where substitution comes in. In order to get 1 where 2 currently is, I can use substitution and substitute angle 1 in for angle 2 to prove step 4 that angle 1 is supplementary to angle 3 using substitution property, or you could just call it substitution. Either one works, the substitution property or substitution. All right, now we've seen 2 examples of substitution property. We're going to finish up with 1 example of the transitive property, and then we are finished with this section. So example 3 here gives us this nice diagram with segments finally. So it says that FG, which is this one here, is congruent to KJ. It also says that GH is congruent to KJ. Well, I already have 1 tick mark on KJ, so that would mean anything else congruent to KJ also needs 1 tick mark. And then I just realized I marked the wrong thing. I marked KG instead of FG. Let's fix this here. FG, there we go. So FG was congruent to KJ, and GH was congruent to KJ. But KJ already had 1 tick mark, so that's why I also added this here. Now I can see visually these 2 segments with the connection of KJ both have a single tick mark. This is where transitive property comes in. I could use these to show that segment FG is congruent to segment GH. All right, here's the thing. What are we even trying to prove here? Is that helpful? But we can do that, sure. Is that going to help us out? My goal is to show that this line KG bisects segment FH. So we're trying to show that this segment is being divided into 2 congruent segments, which in fact would be FG and GH. That's exactly what we need to prove. So this is our connection. So that would mean, by our givens, FG is congruent to KJ, GH is congruent to KJ as well. And then we saw the link. Because both of these segments are both congruent to KJ, that means they're congruent to each other, making FG congruent to GH by the transitive property. So this is by the transitive property. Now, a couple of you might be thinking, Miss Tilly, couldn't I use substitution here? Couldn't I substitute GH in place of KJ because it's congruent to KJ? And technically, yes, technically substitution would be a valid thing to say what happens. But transitive property is nice because it also works like we saw in our example above when I have a whole chain of more than one that would take multiple steps if we're using substitution. So if you are saying congruent angles or segments and connecting them, always use transitive property. If you're just replacing an angle or a segment into a different statement, like complementary or supplementary statements, use substitution. So that will help delineate them here. FG is congruent to GH. And then since we have proved that those 2 segments together that make up segment FH are congruent, that means it's been bisected and that line KG is doing the bisecting. So that means that KG bisects segment FH. And here, we are going back to what it means for a segment to be bisected. This is the definition. If you're unsure how to state this, look back to that definitions card. This is if a line divides a segment into 2 congruent segments, then it bisects the segment. If a line divides a segment into 2 congruent segments, then it bisects the segment. So that is our 3rd example. There is one more in here that we could use to solve this to prove that these are going to be complementary to each other. I'm going to let you try this one on your own and try to work this through. The key to these notes will have this solution worked all the way through to show you as well. And if you would like to work through one additional problem, if you would like to see a system of equations, I'm going to take a couple of minutes and work through this system right now if you would like to see this. But if you feel like you are understanding it or just want to look at the key, the video can stop here. So this next section is optional to watch. Oops. Optional to watch, but it's encouraged if you're struggling with systems of equations. So it's saying here that angle A is complementary to angle B, and angle C is complementary to angle B as well. Couple things to think about here in the context of an algebra problem. So it says angle A is 3x plus y, angle B is x plus 4y plus 2, and angle C is 3y minus 3. Find the measure of angle B. Well, when I look at that, it looks like I will need to determine what x and y are in order to do this. In the context of an algebra problem like this, where we're solving for something rather than proving, it's helpful to think about the definition of complementary in terms of the measures adding to 90. This would mean the measure of angle A plus the measure of angle B is equal to 90 degrees. This also means the measure of angle C plus the measure of angle B is equal to 90 degrees. This allows us to create some algebraic statements and some equations to get started with this problem. One other thing you might be thinking is both those angles are complementary to angle B. This allows us to conclude that angle A is congruent to angle C. They're going to have the same measures. Angle A and angle C are going to be congruent to each other because they're complementary to the same angle. So in order to get started, we need some equations. We need two equations. I'm going to start with this first one, A plus B equals 90, and make this 3x plus y plus x plus 4y plus 2 is equal to 90. Before I do anything else, let's clean this up. This gives us 4x plus 5y, subtract the 2, equals 88. And then from here, in order to keep solving, because this equation has an x and a y, that means I need a second equation. You could either do measure of angle A equals measure of angle B, or you could do this other one that is equal to 90. It is up to you. I'm going to just to switch it up, set the measure of angle A equal to the measure of angle C. So that gives me 3x plus y is equal to 3y minus 3. So looking here, I'm going to get x and y on the same side. This gives me 3x minus 2y is equal to negative 3. So I'm going to move these here. Okay. So now we've got a couple of choices. We could do substitution or we could do elimination. In this case, as I look at this, neither of these are going to be incredibly nice to solve through and solve for y, but what I think I might do, I'm going to solve, see, I'm thinking here, do I want to use substitution? Do I want to solve one of them for x or y and plug them in? Or do I want to do elimination? None of these numbers are going to be great. So this is when I'm going to choose to go for the route of elimination. So here's how this works. I'm going to take equation number 1. I'm going to line them up. 4x plus 5y is equal to 88. 3x minus 2y is equal to negative 3. So if I look at this, my goal is to multiply each equation by some number that would, when I add them together, cancel out either the x's or y's. I'm going to go for the y's. 5 and 2, their most common multiple is 10. So I'm going to multiply the top equation on both sides by 2. and the bottom equation by 5. So I'm color coding so you can see along the way. That makes this top equation become 8x plus 10y is equal to 88 times 2. It's been a while, so let's see here. 88 times 2 is 176. And then let's multiply everything in the blue equation by 5. This gives me 15x minus 10y equals negative 15. Now, I can look and see that if I added these two equations together, which we can do, we can algebraically add equations together, the y's will cancel. And let's add down. 8 plus 15 gives me 23x. And then 176 minus 15 is 161. And, oh, look at that. That is a nice whole number. I wasn't sure if that was going to work out for us here. 161 divided by 23 gives us that x is 7. Awesome. All right, so using this, x is 7. And then now we need to go back and find y. It's up to you. I'm going to maybe pick the blue equation and make this 3 times 7 minus 2y equals negative 3. This gives me negative 2y, this is 21, equals negative 24. So that makes y 12. So we have 12 and 7. Okay, so now that I've sort of spread out with all of my work, what is our goal? Our goal is to find the measure of angle B. So I'm going to move everything over here. So for the measure of angle B, that makes this 7 plus 4 times 12 plus 2. 7 plus 48 plus 2 ends up giving us 57 degrees. And remember, you can always go back in and check your work to verify if A should come out to be, since it's complementary to B, A should come out to be 23 degrees because 90 minus 57 is 23. If you don't get 23, we've got an issue here, but by a quick check, it does look like that works. So our answer is 57. Here's a nice example. So that is it for these notes. We're going to do some more with these as the chapter continues. Big idea is transitive property and substitution property.